and we're going to look at a typical air traffic control problem and a specific one, problem 3-8. And we're going to see if we can understand what's going on and learn how to predict what will happen and therefore, in the end, solve the problem. So we're going to start out with what's a typical problem look like. And I'd like to go back here to do that. In problem 3-8, we have 3 planes. American 12, the blue plane, up here. It's heading, as all these planes are, to Modesto over here. Delta 88, flying on this route to Modesto, and United 74, the pink plane down here, flying up here. These planes are all going to San Francisco, which is 150 miles west of here. So these planes are all up over 30,000 feet, actually at the exact same altitude, and they will stay there when they fly over Modesto. So that's what the basic problem looks like. The goal over Modesto, as you can see, is 3 planes lined up as closely as possible and safely as possible, and that's what we call ideal spacing. As close as possible, but not too close. So we want them 3 miles apart over Modesto, and we want the last plane there to be on a target time of 3 minutes and 48 seconds. And that's what the clock shows, 3 minutes and 48 seconds. Okay? Now let's take a closer look at the goal, because this is very important. You must read the mile markers accurately. 3 miles is what we want spacing. If you get 2, that can be a spacing violation. So you can't read off by one. You cannot read off by 1 mile. Okay? So here's this one exactly on 3. Delta 88's 3 miles past it from Modesto. American 12 is 3 miles from that airplane. Perfect spacing. Target time 3:48. Clock on 3:48. Perfect. That's exactly what we want. So what we're going to do next is we're going to just take the simulator and we're going to run it. We'll select problem 3 and we'll run it, and let's see what happens. We don't know what's going to happen in this particular problem. We have a simulator, we can find it out. Controllers have to predict what's going to happen when the planes show up from the east. We'll learn to do that later on. So let's run the video for this and see what happens.
Welcome to the Smart Skies Line Up with Math Air Traffic Control Simulator. Let's investigate a 3-plane problem. First, click on Select Problem. Mouse over 3 planes and click on Problem 3-8. The goal is to line up the planes over Modesto with ideal spacing, 3 nautical miles, and have the last plane arrive over Modesto at the target time, 3 minutes and 48 seconds. Before Modesto, the plane spacing must never be closer than the minimum separation, 2 nautical miles. Click Play to run the simulator. Fast forward the problem. Note the conflict over Coaldale. We run the problem until it stops. Notice that all 3 planes arrive over Modesto at the same time. The planes do not arrive safely. The spacing and time goals are not met.
So as you can see, we didn't meet the spacing goals and time goals at Modesto. We had a major collision, as well as a collision at Coaldale. So that's not acceptable. Now we know the problem that we have to solve. Those collisions, we have to get exactly the right spacing and the exact time. So that's what we got out of this. Next we'll take the simulator and we'll use it as an experimental tool, and we'll start to look at some solutions to this.